My name is Michael Freitag. I'm the Director of Development for Intech Solutions and the lead developer of the Scan&Solve plugin for Rhino. Scan&Solve was first released in 2011, so some of you are longtime users. Others of you are new, so we'll also cover some of the basics of Scan&Solve. I'm particularly excited to highlight some of the new features and capabilities of Scan&Solve 2014 for Rhino. Among the many new features are support for more types of geometry, controls for higher accuracy, and methods for automation. We'll cover most of these new features today. If at any time you have any questions, please use the chat box or email support@intechsolutions.com. We'll try to answer those questions as they come up. And again, thank you for attending. And so let's get started. So Scan&Solve 2014. I'm going to go through today's plan first. I'm going to start by demonstrating some of the basics of Scan&Solve. Then I'll highlight some of the new features in Scan&Solve 2014, some of the controls on the settings specified in the View tabs. And then I'll discuss working on meshes and extrusions, as well as some of the automation capabilities available through S&S script. As questions come up, as I said, put them in the chat box or email support@intechsolutions.com. So those of you that are not aware, Scan&Solve for Rhino, what does it do? It completely automates basic structural simulation of Rhino solids. It's simple, deterministic, and predictable. The key here is simple. We try to make it as easy as possible to use so that you can incorporate it into your design workflow. Who is it for? It's for any Rhino users with or without expertise in structural analysis. Any user who wants quick and painless performance checks on their designs. This can include architects, designers, engineering educators, students, engineers of all types, marine, mechanical, civil, manufacturing. Basically anyone who uses Rhino. So what makes it special? Scan&Solve works in Rhino on native Rhino solids and requires no pre-processing. So you don't have to go through and repair your geometry, you don't have to export it into an external software, you don't have to go through the painful step of meshing or simplifying your geometry in order to prepare it for analysis. And it doesn't matter what kind of details or complexity you have in your model. So I'm going to run a couple demos here. The first demo, I'll just run a basic simulation from start to finish. And then I'll go back and work through some of the advanced controls that are available with Scan&Solve 2014. And I'll also demonstrate the ability to do simulation with meshes. And I'll finish by covering a little bit of S&S script. So let me go here. And so this is my first geometry. This is Rhino. Just a simple geometry in Rhino. So to do analysis, we're using Scan&Solve. We just type S&S at the command line, choose return, and we choose our geometry. Now, this brings up the Scan&Solve dialog, and it's very simple. We simply work left to right. We start by choosing the material. In this case, I'm going to choose aluminum 6061T6. And the next step is to choose where this geometry is restrained. So this is where it's going to be fixed, maybe to another part of a machine, or maybe it's glued to something. So I choose to add a restraint. Click on the Add Restraint button, and I'll choose this back face here. Click Return, and we've just added a restraint, and you see the back face here is annotated with restrained icons. Next step is we'll add some loads. Choose Add in the Load group, and now we need to select the faces that we're going to apply these loads to. So I'm going to click and drag, and I've now just selected all of these faces on this front, or on the right here. Choose Return, and here we see the load, or the Boundary Load Creator dialog pop up. I'm going to do the simplest load right now, which is just a vector force. We'll enter this by component, and I'll enter a force of 0 newtons in the X, 0 newtons in the Y, and 5,000 newtons in the negative Z direction. And I will also choose the per face option. So what this does is it means that 5,000 newtons is applied to the circular face, there's 5,000 newtons applied to the square face, 5,000 newtons applied to this I-shaped face, 5,000 newtons applied to the H-shaped face, and so on down the line. If I did not choose the per face option, then that 5,000 newtons would be distributed in proportion to the individual areas. It would be 5,000 newtons applied total, and it would be distributed based on the areas of the individual faces in proportion, in their individual proportions. I click OK, and now we choose a resolution. This is a new feature in Scan&Solve 2014. The maximum resolution is 500,000 elements, which is quite a bit for this geometry. So, and you also don't want to sit around and wait for that to solve. So I will choose the low value of 10,000, and then click the Go button. In this step, now it starts processing here. So what it's doing is actually building a mathematical approximation of the structural behavior of the shape, applying the loads and restraints, and taking into account the material properties. And in just a couple seconds, we'll see another new feature in 2014, which is the animation of the solution of the solving process. What it's doing here is actually displaying the intermediate solutions, because in the iterative solution process. So as it goes through, you'll see that the solution will actually change over time until it comes to a converged state. So that now we have finished our solution, and we can click on the View tab and we can view the results. So the first thing we see here is the danger level. So the danger level is a measure of the material utilization. So 0 corresponds to a location where the material is not stressed anywhere near its capacity, and 1 is a location where the material is stretched to its, or is being stressed to its capacity, and anything greater than 1 is beyond its capacity. So we're going to see probably plastic deformation in those regions. So 0 corresponds to the blue regions, and 1 corresponds to the red regions. On the View tab, we can see what a magnified view of what the deflection looks like. So this is as if we're applying the load, and the deflection we're seeing here is actually magnified by, in this case, 19 times. So this is the deflection you see here is 19 times greater than it would be in actuality. Now, if you're interested in a particular the locations where our danger level is, say, high or low, you can go into the marking group and choose. We'll choose the maximum. Find the location of the maximum. We click the max button, and it will insert. Scan&Solve will insert a leader into the document showing where the location of the maximum danger level is, as well as the magnitude of that value. And this works for any solution component that we might choose to display. We can also choose the minimum, location of the minimum, which is right down here. That's basically 0. And we can also choose to, if you're interested in the value at a point, we can choose the point button and choose a location on the geometry where we are interested in the value, and it will insert a leader there. Now, if we are done cluttering our model, we can just click the clear button, and those restraints will go, or those annotations will go away. On the View tab, we also have the section plane option, so you can turn on a section plane and see what the solution looks like on the inside of the geometry. You can choose different axes as well as different orientations of the section plane. Another interesting feature here is the ability to actually bake the results. For example, if you want to do 3D printing, say in color, or even not in color. So to see the in order to prepare something like this for 3D printing, we can choose the Bake button. When you click the Bake button, you can output the geometry into the document, or externally. So if I were to choose a Rhino mesh object, I can choose to apply, insert this a meshed the meshed version of this deformed geometry into the Rhino document with texture applied. So if I choose Save here, I've just chosen the location for the texture and click OK, and you can see that it's just incorporated the deformed shape into the Rhino document. Now if I go back to into a rendered view, you'll see the textured view. This will actually persist outside of Scan&Solve, so that might be useful for rendering. There's a couple other options for baking. You can also bake this as plain geometry, or you can also into Rhino, so you can actually just see what this looks like without texture applied, or you can export as STL, PLY, or VRML2 as external files for, say, 3D printing by one of those 3D printing services. We can also generate reports in web format for output to, or for publishing to colleagues or publishing on the web, and that's as simple as clicking the report button and choosing a location for our report. And Scan&Solve will go through and generate a web-ready report. This is an HTML format. We start with showing the geometry. In this case, I've already got this other one stuck in there, so it's a little overlap, but it's there. There's the geometry we're doing analysis on. There's a little bit of information about the geometry, information about the material properties we're using, the loads and restraints we've got applied, and then there's some technical information about the simulation as well as the units that we are using. There's the displacement results, and finally the danger level results. I'm going to click out of here and get rid of this geometry so it doesn't interfere anymore. Go back in here. So now let's go through some of the new features in Scan&Solve 2014. One of the new things in Scan&Solve 2014 is the ability to show the actual solution grid. This is the grid on which, oops, I just switched views here, shaded. This is the simulation grid over which our structural simulation is computed. And you can see that it updates in real time as I adjust the resolution. And you'll see that as I increase the resolution, the size of the elements goes down, which increases basically the accuracy that we're going to achieve at a given resolution. Another new feature in Scan&Solve 2014 is the ability to choose different solvers. The default solver is the Scan&Solve solver, which, as I said, is an iterative solver, which also supports the display of the solution process in real time. The next one is the ISS solver. This is also an iterative solver, which is slightly faster than the Scan&Solve solver, but it doesn't support the animation of the solution results as the solution proceeds. It also takes a little bit more memory than the Scan&Solve solver. And then the fastest solver is the DSS solver. So this one is probably the best one to use in general, but it can be a bit of a memory hog, so it is probably best to be used on geometries that you can safely analyze at, say, resolutions less than probably around 200,000 elements on the typical computer. So in my case, I've got 10,000 elements, so the DSS solver works just fine for this. And now I've selected the DSS direct solver, and then I can go back to the specify tab, and we can see the results of making that change. In this case, the the building of the linear system takes the same amount of time, but you'll see as soon as it gets to the solving step, it's virtually instantaneous. There, we've got a result. We've got our results already. So if I go back to the Specify tab here, another new feature in Scan&Solve 2014 is the ability to actually edit restraints and loads, at least the faces to which they're applied, as well as their actual specification. So to do that, we click on, say, the restraint we want to edit. We choose Edit, and there's a new button here in the restraint editor called labeled Edit Geometry. If we choose Edit Geometry, we're into a selection mode where we can actually select different faces to which our restraint is going to be applied. So you've seen that I've just edited basically the faces to which that restraint is applied. I've moved it from the back face to the two side faces. I can also do the same thing with loads. I choose this load, choose Edit, and here we see the Edit Faces button. Choose Edit Faces, and I can unselect some of these faces. Click Return, and now the load is only applied to these other faces. Also choose to edit, say apply a face or apply it to that face there. Choose OK and click Go. We'll see the results shortly here. So here's the results with those new loads applied, new restraints and loads applied. So on the View tab here, we've also, in Scan&Solve 2014, we've also added some new solution components. One of those that's of interest, especially to architects and students of architecture, is the regions of tension and compression. So the architects are interested in the locations where they need to put in their reinforcement. So they're interested in particularly the regions where the geometry is under tension. So we choose the principal tension and compression solution component, and red corresponds to regions that are under tension. So if I center this scale, we'll be able to see it more clearly. Oops, that's too far. Negative 200. So 0 is now in the center, and blue corresponds to regions that are under compression, and red corresponds to regions that are under tension. So if you're an architect, you would probably concentrate your restraint or your reinforcement, if this is concrete, in the regions where the red is being shown. Another component that we've added in 2014 is the strain energy density. This is a quantity that's often used for optimization purposes, so that's available, and it's probably more useful for those that want to maybe put Scan&Solve into a loop using SNS script. Another new feature in Scan&Solve 2014 is the ability to select a different font for the legend as well as the legend color. So if you want to choose a color that contrasts more readily with whatever background you have, you can do that. There's a question, did the three solvers provide the same accuracy of the results, assuming the resolution is the same? Yes, the solvers basically solve the same equations. They just use different algorithms to do it. So the results will actually be the same. There is on the settings, on the Specify tab, the settings tab, there's a precision entry here. By choosing this is only effective on the Scan&Solve solver. So if you choose a lower resolution, then you can, or a lower precision, then these iterations of the solver will stop sooner. So in that way, you can actually decrease the accuracy of that last solver, but you'll get your answers sooner. So another new feature in Scan&Solve 2014 is the ability to work on meshes. This is a big change from the previous versions of Scan&Solve. Previously, you had to use the mesh to NURBS command to convert your geometry from a mesh representation to a poly surface, a closed valid poly surface. And unfortunately, fortunately or not, the mesh to NURBS command is limited in the number of triangles that it will support. So if we do the what command on this actually has 98,000 vertices or 33,000 polygons, which is actually a reasonably sized mesh, and it would almost go through the mesh to NURBS command. But there's actually some selection features that are nice in Scan&Solve 2014 to make it easy to apply loads to this. So we've added those. So in order to do analysis on this, what we'll probably want to do is we want to simulate the thrust load on these blades due to this propeller moving through the water. So what we'll do is we'll restrain the spline on the inside and then apply a load on the bottom faces of these blades. So to select the spline surface, we could go there and individually select all these triangles, but that's kind of a pain. So we'll use the insolid command, which is new for Scan&Solve 2014 and the mesh operation. So what I'm doing here is actually creating an auxiliary geometry which encloses the faces of these of the spline, and we'll use that later for inside the Scan&Solve. So let me show you in a ghosted view. You can see that the cylinder encloses that spline, or all the faces of that spline, all the way through. So to do analysis on this mesh, we choose SNS, or we type SNS at the command line, click on the mesh, and we're presented with the Scan&Solve dialog. So the same operation, we work left to right. In this case, I'm going to choose stainless steel. And I'm going to choose to restrain the spline on the inside. And when I choose the Add button, we can see that we have two options here. We have connected and insolid. So these are the options for selecting mesh faces. So I choose the insolid option, and then select the solid that encloses that spline, the faces of that spline. Click return, and we see that we've added a restraint on those spline surfaces. I want to add a load, and also in the add load I will show the other option for selecting mesh faces, and that is the connected option. So I choose the connected option, and this operates the same as some of the mesh selection tools in Rhino. So what we do is we select a seed facet, and the Scan&Solve will collect mesh faces out to a given break angle that we specify in this dialog. So by choosing an angle of 4 degrees, it selects all of the mesh faces that are connected to that initial seed facet with a break angle less than 4 degrees. And I can choose more seed facets by clicking the Edit Selection button. And I'll go through and select some more faces, hit Enter. And now you can see that I've selected all the back faces or all the downward faces of the blades. Click OK and enter one more time, and now I'm going to apply my load. And this load is being applied to the bottom faces of these blades, and I'm just going to again do a vector force 0, 0, and 2,000 newtons. So this is a force being basically this is the reaction force of the water against the propeller as the propeller is forcing the boat through the water. We click OK, and when we've got that load applied, we can choose a different resolution. In this case, I'll run 10,000. Choose the direct subbar solver again. Specify, click Go. Now, while this is solving, I will show another new feature, which is the ability to work on lightweight extrusions. So this is a new geometry type that was added in Rhino 5. So instead of being a full poly surface, this is represented as an extrusion, which is a cross-section with a sort of a profile. Usually I think they're actually straight profiles. Previously, this you would have to use in Scan&Solve prior to 2014, you would have to use the convert extrusions command to convert this from a lightweight extrusion to a poly surface that could be operated on in Scan&Solve. But we can do it directly in Scan&Solve now, 2014, by S&S, click on the solid, and choose the material restraints, same as usual. Click Add Load, enter. And while I'm here, I will also talk about some of the other types of loads we can apply. So in the past couple of examples, I've just been using the vector force and entering it by component. But we can also enter vector force by direction and a magnitude. So I select that radio, click on direction, and now I'm specifying direction. And now I'm specifying the direction that I'm going to be applying my load by picking 2 points in the window. So in this case, it's 1,200 newtons in the direction that I chose. I can also apply a scalar force. The scalar force gets converted to a pressure by taking the force you specify and dividing it equally among the faces to which you're applying the force. And the scalar force is also applied normal to the surface. So in this case, I say 200 newtons, and you can see that it's applied directly into that face. I can also apply pressure. So this is where you would specify the pressure directly. So say 100 megapascals would be directly applied to that face. You can also enter a pressure expression, which is a function. You can enter an equation that represents the pressure being applied to the surface. And this can be an equation in terms of x, y, and z. So say x squared plus y squared. And you can see, maybe, hopefully, that the magnitude of the force is higher over here and less over here. And it probably is. It's a parabola based centered right around here, around the origin. You can also do functions of times, trigonometric functions of x times y, all kinds of fancy stuff there. We can also apply hydrostatic loads. So hydrostatic load, you specify the plane of the surface of the fluid in which this is submerged. And it includes F8. As well as the density of the fluid. So like water would be 1,000 megagrams. Oops, sorry. We'll switch to kilograms. So it's 1,000 kilograms per cubic meter. And you can see the force or the pressure is it's actually uniform in this case because it's my plane is normal to that surface. I can also apply torques. To apply a torque, you specify an axis, and the torque around the axis. So, and using the right-hand rule. I specified that a little funny, so it's a little bit small. But the axis is somewhere over here on the right. I can't go here and it'll solve. So we switch back to the propeller. Results are done here. Choose view, and you can see the results on a mesh. See the deflected results. Same as working with a regular solid or a poly surface. Okay, so one more thing to show, and that is the automation capabilities that are now available through S&S Script, which has been added into Scan&Solve 2014. With automation, you can, with S&S Script, it allows you to do a lot of the functionality of Scan&Solve, but perform it in an automatic fashion through Rhino script. So a couple examples here. Here we see a geometry. If I run Scan&Solve on this geometry, you can see that we actually have a solution already displayed. We can see what the deflected results look like. But as soon as I get out of Scan&Solve, the results are no longer displayed. So with S&S Script, we can actually turn on the display of the solution through scripting, and then the results are displayed automatically. So I choose this particular solid in this script. Sorry, I should have showed the script first. The script, all it does here is there's a little preliminary stuff here. It loads the script, it loads S&S Script so that we can actually perform the S&S operations. It asks for a solid to apply our operations to, and in this case what it does is actually turns on the display. So here we see the results displayed on this shape. This script is basically the same thing, but it turns off the display. I run it, select solid, turns it off. This script is pretty simple. Well, it actually does something kind of cool. It actually will output the frames, the deflected shape of this as frames that you could be, as images that could be input into, say, a video editing software. So if I run this, I can specify the maximum deflection scale factor, say about 10,000 times. The number of steps, or the space between the steps. So I'm going to do 500 between steps. And now it's going to ask me for an output. I'm going to go to the desktop and frames. And finally select the solid. And what it's doing right now is actually going through and creating 20 different frames of the results in sequence. So here we have a deflection scale of 0, 500, 1,000, 15, 12, 2,000, 3,000, 4,500, and then finally it ends at 10,000. So these are all just images that have been output from S&S Script as images that can be input into, say, a video editing software. There's a lot more functionality that's available, but I can't discuss all of it. I have to find my browser window here that actually has the documentation. It's here somewhere. Oh, here it is. So there's an introduction to S&S Script here, and then there's a couple, I guess, what is it, 6 examples, a short example, and then Here is one of the questions that came up earlier was a question of how to compute reaction forces. And this script actually computes reaction forces by allowing you to select faces on which you are going to select in which you're interested in the forces. So there's a lot of functionality here. There's a lot of documentation. So if there's any, we can also generate scripts for you if you're, or at least help you, guide you through that process. I'm going to go back to my presentation and close with links for information if you want to learn more. You can go to our forum, which is scanandsolve.com. And these are, you can ask your questions here and get a public answer. Or if you don't want to share your question publicly, you can email us at support. You can also visit our YouTube channel, which shows a lot of our functionality as we edit it over time. There's probably the last one was the tension and compression capability. This is a demo of using SNS script to extract bending moments, and there's a lot of different ones here. And I have to point out that we are running a special right now through June 18th, which will be the official launch date for Scan&Solve 2014. We're offering 40% off of upgrades from any version 1.x of Scan&Solve, and 20% off on any new licenses. Thank you for your attention. We hope to hear from you soon.